Expanding on our knowledge that we have now of multiplying radicals, we're actually now going to multiply two binomial expressions that have radicals in them. And as we can see here on this one on the left, we've got 6 times the square root of 3 minus 5 times 2 times the square root of 5 plus 4 times the square root of 2. I'm going to use our old friend FOILing. So let's see. There's our first. So I look at that and I got 6 times the square root of 3 times 2 times the square root of 5. Well, let's see. 6 times 2 is 12. And the square root of 3 times the square root of 5. Remember, when we're multiplying, we can multiply the numbers under the radical. We can't add them that way. We got to have the same radicand to add them. But the square root of 3 times the square root of 5 is the square root of 15. There's our first. Then let's look at the outer. 6 times the square root of 3 times 4 square root of 2. Well, 6, and this is a positive, so 6 times 4 is 24. And the square root of 3 times the square root of 2 is the square root of 6. And now let's do our inner. We got negative 5 times 2 square root of 5. Well, that's going to give us negative 10 square root of 5. And then finally our last terms, negative 5 times 4 square root of 2. And negative 5 times 4 is negative 20 with the square root of 2. And Shazam, that's our answer. Let's see, 15, I can't pull out any perfect squares of that. Square root of 6, can't pull anything out of that. Square root of 5, can't do anything with that. Square root of 2, really can't do anything with that. And that's my answer. That's it. That's as far as I could simplify it. Well, let's look at the next one. We got 7 times the square root of 2 minus 3 square root of 3 times 7 square root of 2 plus 3 square root of 3. And when I look at that, these two binomials are conjugates. Look at the difference there. One of them's got a negative sign in there, minus 7 square root of 2 minus 3 square root of 3. And the other one is 7 square root of 2 plus 3 square root of 3. And the good thing about multiplying the conjugates, when I get through with this, I shouldn't have any radicals left in this expression. Let's see if that's true. All right, so we got our first. 7 square root 2 times 7 square root 2. Well, that's 49 square root of 4. 7 square root of 2 plus 3 square root of 3. That's going to be plus 7 times 3 is 21. Square root 2 square root 3 multiplied together is square root of 6. That was our outer. Let's do our inner. Negative 3 square root of 3 times 7 square root of 2. Well, negative 3 times 7 is negative 21. And square root of 3 square root of 2 is square root of 6. And you might notice those are going to cancel. That's the nice thing about conjugates. And then we got our last is negative square root of 3, negative 3 square root 3 times 3, positive 3 square root 3. Well, negative 3 and positive 3 is negative 9. And square root 3 is the square root of 9. Well, I can cancel these. Then I've got a little bit more work to do. Well, let's see. 49 square root of 4, that's the same as 49 times 2 minus 9 square root of 9. Well, that's 9 times 3. And let's do a little bit of multiplication here and finish this thing off. Let's see. 49 times 2, that's 98. And negative 9 times 3 is negative 27. And so now we got 98 minus 27. Well, that's 71. And isn't it interesting how these conjugates right here end up and all our radicals go away. Bye-bye, bye, 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 bye. And we end up with 71.